Good morning, students. We have been discussing the various method to solve the integrations. So the integration on the method of partial fractions is what we have been discussing. So already second Roman two problems from 6D exercise already we have started. And this is the third problem, integral 2x square plus x plus 1 by x plus 3 into x minus 2 whole square dx. So this is the numerator and denominator contains the polynomials in x, and this is a fraction, and the degree of numerator is 2 and the degree of denominator is x into on expansion of this x square. So x cube we will be getting. So degree of f of x is less than degree of g of x. Hence this is a proper fraction, and the method of partial fractions is applicable for proper fraction. So here the denominator contains x plus 3, which is a form of ax plus b, which is a linear factor, non-repeated linear factor. As far as x minus 2 whole square is concerned, this is also a linear factor, but it is a repeated linear factor, repeated twice. So non-repeated linear factor type 1, repeated linear factor type 2. So this is the combination of type 1 and type 2. So let us first take without integration. Consider 2x square plus x plus 1 by x plus 3 into x minus 2 whole square. So the partial fraction for this is a by x plus 3. For every non-repeated linear factor ax plus b, there exists a partial fraction of the form a by ax plus b. This is a repeated linear factor, b by x minus 2 plus c by x minus 2 whole square. So this implies 2x square plus x plus 1 by x plus 3 into x minus 2 whole square is equals to the LCM for which is x plus 3 into x minus 2 whole square. So this by x plus 3, these two gets cancelled. X minus 2 whole square into a is a into x minus 2 whole square plus. So this by x minus 2 cancel in one time. So x minus 2 into x plus 3 into b. So b into x plus 3 into x minus 2 plus this by x minus 2 whole square. This and this gets cancelled. So we are left with x plus 3 into c. So c into x plus 3. So the denominator on both the sides gets cancelled. Therefore we are left with 2x square plus x plus 1 is equals to a into x minus 2 whole square plus b into x plus 3 into x minus 2 plus c into x plus 3. So here the denominator contains linear factors x plus 3 and x minus 2. Therefore we are going to take x equals to minus 3 and x equals to 2 and will substitute. Put x is equals to 2. So on substituting 2 here, 2 square is 4, 4 2s are 8, plus 1 9, 9 plus 2 11. So this term would be cancelled because 2, if you substitute here, 2 minus 2 is 0. So 0 square into a, this is all 0. Here also it will be 0. We are only left with the last term, c into x value is 2, we are substituting 2 plus 3 is 5. So from this, c is equals to 11 by 5. Now, put x is equals to minus 3. Let us substitute here. Minus 3 whole square is 9. 9 2s are 18. 18 plus 1, 19. 19, x value is minus 3. 19 minus 3 is 16. Is equals to. So, minus 3 when we substitute here and here, these terms would be cancelled because minus 3 plus 3 is 0. Here also the same. Now a into the value of x is minus 3 minus 2. Minus 3 minus 2 is minus 5 whole square, which is 25. So this is equals to a is equals to 16 by 25. Now, so we are done with this x equals to something here, and let us compare the coefficients. So comparing the coefficients of x square on both sides. So x square quotient in the LHS is 2. Here on expansion of this x square minus 4x plus 4. So x square quotient is a. Here x into x is x square quotient is b. So a plus b is equals to 2 we get. So already we get the value of a. So from this we will obtain b. b is equals to 2 minus a. So 2 minus the value of a is 16 by 25. So 25 2s 50. 50 minus 16 is 34 by 25. So therefore the values of a, b, c are this what we got. So let us substitute. So a is equals to 16 by a value is 16 by 25 by x plus 3 is 25 into x plus 3. And the value of b is 34 by 25. That is 34 by 25 into x minus 2. And the value of c value is 11 by 5 by x minus 2 whole square. 11 by 5 by x minus 2 whole square. A by b by c. A by bc. So 11 by 5 into x minus 2 whole square. So this is 11 by 5 into x minus 2 whole square. So this I am rubbing. Now, so 2x square plus x plus 1 by x plus 3 into x minus 2 whole square's value is this we have got so far. So now let us integrate. Now integral of 2x square plus x plus 1 by x plus 3 into x minus 2 whole square dx. So this is integral of dx. So in the place of integral dx I have written. So 2x square plus x plus 1 by x plus 3 into x minus 2 whole square. So this value we have already prepared through the process of partial fraction. So in the place of this, let us write this. 16 by 25 into x plus 3 plus 34 by 25 into x minus 2 plus 11 by 5 into x minus 2 whole square whole day. So let us distribute integral dx to each of these. Then we'll get integral 16 by 25 into x plus 3 dx. So let us separate the constant from the process of integration. So 16 by 25 into 1 by x plus 3 dx plus, since 34 by 25 is constant, let us separate it also from the process of integration. So 34 by 25 integral 1 by x minus 2 dx and 11 by 5 I have separated this from the process of integration. 1 by x minus 2 whole square dx or dx by x minus 2 whole square. So this is equals to 16 by 25. So this is of the form integral 1 by x dx log mod x. So integral 1 by x plus 3 dx is also log mod x plus 3 plus 34 by 25 log modulus of x minus 2 plus integral 1 by x square dx is minus 1 by x. So 11 by 5 into minus 1 by x minus 2. So plus into minus is minus. So this is minus 11 by 5 into x minus 2 plus constant of integration c. The fourth question is integral dx by x cube plus 1. So first of all, this is a proper fraction with the degree of numerator is 0, because this can be written as 1 by x cube plus 1 into dx. 1 can be written as x power 0. So the degree of numerator is 0 and the degree of denominator is 3. But if you see the denominator, so this denominator is a cubic equation. So actually, as far as partial fractions we have discussed so far, the denominator either contains a linear factor or quadratic factor. So we did not encounter any such type of cubic factors. So let us first factorize this cubic factor into the product of linear or quadratic factors. First, let us do that. So consider x cube plus 1. So 1 can be written as 1 cube. So this is the form a cube plus b cube. What is a cube plus b cube? A plus b into a square minus ab, x into 1 x plus b square. A cube plus b cube, a plus b into a square, x square minus ab, x into 1 x plus b square, 1 square 1. So now take 1 by x cube plus 1. So this is equals to 1 by, what is x cube plus 1? X plus 1 into x square minus x plus 1. Now the denominator contains x plus 1. This is the form ax plus b, a linear factor and a quadratic factor. And let us analyze which kind of quadratic factor it is. Is this a reducible quadratic factor or irreducible quadratic factor? If it is a reducible factor, then so it will be treated in one way. Otherwise, if it is an irreducible quadratic factor, then it goes in type 3. So let us first take this x square minus x plus 1. X square minus x plus 1. So compare this with ax square plus bx plus c. So here a is equals to 1, b is equals to minus 1, c is equals to 1. So what is b square minus 4ac? B square is minus 1 whole square minus 4 into 1 into 1. So minus 1 whole square is 1 minus 4, which is minus 3. Minus 3 is less than 0. If b square minus 4ac is less than 0, this quadratic factor doesn't have any linear factors, any real factors. Okay, so therefore this is an irreducible quadratic factor. So the denominator is the combination of a linear, non-repeated linear factor and non-repeated irreducible quadratic factor. Non-repeated linear factor type 1. Non-repeated irreducible quadratic factor type 3. Non-repeated linear factor, for every non-repeated linear factor ax plus b, there exists a partial fraction of the form a by ax plus b. This is x plus 1 plus. For every non-repeated irreducible quadratic factor ax square plus bx plus c or px square plus qx plus r, there exists a partial fraction of the form ax plus b by ax square plus bx plus c or px square plus qx plus r. Since a is already introduced, so this is bx plus c by x square minus x plus 1. So let us rub this. So this is equals to 1 by x cube plus 1 is equals to, the LCM is x plus 1 into x square minus x plus 1. So this is a into x square minus x plus 1 plus bx plus c into x plus 1. So x plus 1 into x square minus x plus 1. This is x cube plus 1 only. Because x cube plus 1 is x plus 1 into x square minus x plus 1. X plus 1 into x square minus x plus 1 is x cube plus 1. So this as well as this gets cancelled. Therefore, we are left with 1 is equals to a into x square minus x plus 1 plus bx plus c into x plus 1. So here we have linear factor, x plus 1 linear factor. So equated to 0, x equals to minus 1. And x plus 1 is a factor, while x equals to minus 1 is the root of solution. As far as the root of solution is concerned, so after substituting it into the given equation, the equation gets satisfied. In that way, one of the three values we are going to get. So put x is equals to minus 1. So 1 is equals to a into minus 1 whole square is 1 minus of minus plus 1 plus 1. So minus 1 when we substitute here, it will be 0. Minus 1 plus 1 is 0 into something is 0. So this is 3a is equals to 1 or a is equals to 1 by 3. Likewise. Now let us compare now. Comparing the coefficient of x square on both sides. So the x square quotient in LHS is 0 because we don't have any x square term here. So 0 is equals to here ax square minus ax plus a. So x square quotient is a. Here bx into x, bx square. X square quotient is b. So a plus b equals to 0. From this, b is equals to minus a. So minus 1 by 3. Now, comparing constants on both sides. So the constant in LHS is 1. So 1 into a is a plus. So bx into x is bx square. That is x square term. Bx into 1, bx, that is x term. But we c into x, cx, that is x term again. But we are looking for the constant. So c into 1 is c. So that c we will take. So from this c is equals to 1 minus a. So 1 minus a is 1 by 3 which we have got earlier. So 3 ones are 3, 3 minus 1 is 2 by 3. So this is c value. So let us substitute a, b, c values which we have got so far in this. So the value of a is 1 by 3. So 1 by 3. And the value of b is minus 1 by 3. So this is minus 1 by 3. And the value of c is 2 by 3. So this is what we have got so far. Let us erase this. So a by b by c is a by bc. So this is 1 by 3 into x plus 1 plus. So let us take 3 as an LCM here. Then this is 2 minus x by x square minus x plus 1 is x square minus x plus 1. So here 3 I have taken LCM. So this is 2 minus x by 3 by x square minus x plus 1. By 3 by x square minus x plus 1 is by b by c is b into c. So now let us integrate. So dx by x cube plus 1 is equals to integral 1 by 3 into x plus 1 plus 2 minus x by x square minus x plus 1 whole dx. So this is equals to 1 by 3 into 1 by x plus 1 dx plus this is integral 2 minus x by x square minus x plus 1 dx. This we know how to do this. This is just like integral 1 by x dx log mod of x plus 1. So this is okay. But as far as this is concerned, remember this kind of method we have discussed before as well. This 2 minus x is a linear expression and x square minus x plus 1 is a quadratic expression. So linear expression is equals to a into d by dx of a quadratic expression plus b. So in that way, let us solve this. Consider 2 minus x now. So 2 minus x is equals to, consider 2 minus x by x square minus x plus 1. So 2 minus x is equals to a into d by dx of quadratic plus b. So this is equals to 2 minus x is equals to a into d by dx of x square is 2x minus d by dx of x is 1, one derivative is 0 plus b. So let us compare the coefficient of x on both sides. So this is minus 1 is equals to, this is 2a. From this, a is equals to minus half. Likewise, comparing the coefficient of, comparing constants on both sides. 2 is equals to minus a plus b. So from this, 2 plus a is equals to b, 2 plus minus 1 by 2. So 2 minus 1 by 2 equals to b, 2 to the 4, 4 minus 1. So b is equals to 3 by 2 we get. So a is equals to minus half and b is equals to 3 by 2. So a is equals to minus half and b is equals to 3 by 2. So this is what we have obtained. So let us erase this. So 1 integral dx is equals to integral 1 by 3 into, this is 1 by x plus 1 dx plus 2 minus x by x square minus x plus 1. So 2 minus x we have already prepared here. So this is minus 1 by 2 into minus 1 by 2 into 2x minus 1 plus the value of b is 3 by 2 by x square minus x plus 1 integral dx. So 2 minus x is minus 1 by 2 into 2x minus 1 plus 3 by 2. So 2 minus x is replaced as minus 1 by 2 into 2x minus 1 plus 3 by 2 by x square minus x plus 1 is same. So integral dx, integral dx. So this is all. Let us run. So this is equals to 1 by 3 integral 1 by x plus 1 dx plus earlier here 1 by 3 has been missing. So this is 2 minus x by 3 into x square minus x plus 1 and 2 minus x is this what we have got now. So this is 1 by 3 integral this is a plus b by c, a by c plus b by c. So plus into minus is minus. 1 by 3 into 1 by 2 is 1 by 6. So this is 2x minus 1 by x square minus x plus 1 dx plus 1 by 3 into 3 by 2 integral 1 by x square minus x plus 1 dx. So these two gets cancelled. So 1 by 3 integral 1 by x plus 1 dx minus 1 by 6. This is x square minus x plus 1's derivative is 2x minus 1. X square derivative is 2x minus x derivative is 1. 1 derivative is 0. So this is of the form f dash x by f of x is log mod f of x. So let us write that step as also once x square minus x plus 1 dx plus this is 1 by 2. So this is a pure quadratic expression and we know how to deal with this quadratic expression. So completion of square method, x minus a minus b whole square or a plus b whole square. So this is 1 by x square is x minus x square x I am taking, x coefficient is 1, half of that. So 1 by 2 complete the square minus 1 by 2 whole square is 1 by 4 plus 1 is as usual. So this is dx. So this is 1 by 3, 1 by x plus 1 dx minus 1 by 6 into 2x minus 1 by x square minus x plus 1 dx plus 1 by 2. So this is 1 by x minus 1 by 2 whole square. 4 ones are 4, 4 minus 1, 3. So 3 by 4 is root 3 by 2 whole square dx. So this is 1 by 3. Integral 1 by x dx is log mod x, log modulus of x plus 1 minus 1 by 6. This is f dash x by f of x is log mod f of x, log modulus of x square minus x plus 1 plus 1 by 2. This is of the form integral 1 by x square plus a square. 1 by x square plus a square is 1 by a tan inverse x by a. So 1 by a is root 3 by 2 tan inverse x by a. X minus 1 by 2 itself is x by a is root 3 by 2 plus constant of integration c. So here 1 by root 3 by 2 is 2 by root 3. 2 gets cancelled. Therefore the final answer we get it to be 1 by 3 into log mod x plus 1 minus 1 by 6 log modulus of x square minus x plus 1 plus 1 by root 3 tan inverse of this is 2x minus 1 by 2 by root 3 by 2. 2 gets cancelled. 2x minus 1 by root 3 plus constant of integration c. So this is the last question from this exercise 6e. Sin x cos x by cos x cos square x plus 3 cos x plus 2. Here cos x derivative is sin x. Let cos x is equals to t we will take. Cos x derivative is minus sin x dx is equals to dt. So let us substitute in this. So cos x is t, sin x dx is minus dt by this is t square plus 3t plus 2. Let us consider t by t square plus 3t plus 2. So here t's coefficient t's degree is 1 and t's degree is 2 in the denominator. So degree of numerator is less than degree of denominator. Therefore this is a proper fraction again. And the denominator contains a quadratic factor. Let us analyze which quadratic factor it is. I mean reducible quadratic factor or irreducible quadratic factor. Reducible quadratic factor is that quadratic factor which has got the further factors. So which can be expressed as the product of two or more linear factor. So t square plus 3t plus 2, its factors are t plus 1 into t plus 2. T square quotient is 1, 2s are 2. So factorization, completion of the square method, completion of the middle term method, splitting of the middle term method. So 1, 2s are 2, 2, 1s are 2. So 2t plus 1t. So t square plus 1t plus 2t plus 2. So t if you take common t plus 1, 2 if you take common t plus 1. So t plus 1 into t plus 2. So this is t by t plus 1 into t plus 2. So the denominator, now this quadratic factor has become the product of two linear factors. So since the denominator contains two non-repeated linear factors, for every non-repeated linear factor there corresponds to a partial fractions of the form a by t plus 1, b by t plus 2. A by t plus 1 plus b by t plus 2, where a and b are to be evaluated. So a into t plus 2 plus b into t plus 1 by t plus 1 into t plus 2 is equals to t by t plus 1 into t plus 2. So these two gets cancelled. So this implies t is equals to a into t plus 2 plus b into t plus 1. So the values of a, b are to be obtained by substituting t equals to minus 2 and t equals to minus 1. Why? You know the reason. So put t is equals to minus 2. So minus 1 is equals to a into minus 1 plus 2. 2 minus 1 is 1. So from this a is equals to minus 1 we got. Likewise, put t is equals to minus 2. So minus 2 is equals to minus 2, if you substitute here it will be 0. So b into minus 2 plus 1 is minus 1. So from this b is equals to 2. Therefore a is equals to minus 1 by t plus 1 and b value is 2 by t plus 2. 2 by t plus 2. So this is equals to this I'm rubbing. Now integral of t by t square plus 3t plus 2 dt is equals to integral of minus 1 by t plus 1 plus 2 by t plus 2 whole dt. So t by t square plus 3t plus 2 is this integral dt. So we have minus here. So here also we will get minus. So minus into minus is plus. So 1 by t plus 1 dt. Minus into plus is minus. 2 I am separating it from the process of integration. 1 by t plus 2 dt. So 1 by t plus 1 is log modulus of t plus 1 minus 2. 1 by t plus 2 is log modulus of t plus 2 plus constant of integration c. So this is equals to log t plus 1 minus m log a is log a to the power of m. So log, this is t plus 2 whole square plus c. Log a minus log b is log a by b. So log of t plus 1 by t plus 2 whole square plus c. So log the value of t which we have taken earlier it to be cos x. So cos x plus 1 by cos x plus 2 whole square plus c. So this is the final answer.